Alright, so here we are with Unit 11 and Lesson 1. I'm going to quickly run through. There are a lot of terms here, but most of these you don't need to worry about the definitions for. I'm going to give you these three. You should know the definition for fermentation, halide, definitely hydrocarbon, and definitely isomer, and definitely organic chemistry, polymerization, saponification, unsaturated and saturated. So there's only some of them, less than half of those terms do you really need to know the definitions for. And of course underneath that is going to be the objectives. This is what you should be able to do when you're done with the unit. So let's get into sort of a introduction to organic chemistry. Organic chemistry, here's kind of the definition, is the study of compounds that contain carbon and hydrogen. Generally, it's the study of compounds that contain carbon, but most compounds that contain carbon also contain hydrogen. What makes this so special? Well, one of the things they ask you about is, and this is not something that's really known, there are probably, I'm going to say 100,000 inorganic compounds, meaning compounds that don't necessarily contain carbon, but there are millions of organic compounds. Why is that so? Well, it's so because of the element carbon. Carbon is unusual in that it has 4 valence electrons, and it has to form 4 bonds. So not only can carbon form 4 bonds with other elements, for example, it can form bonds with 4 hydrogens, or it can form 4 bonds with a hydrogen, a chlorine, a fluorine, and a bromine, but it can also form bonds between itself, meaning you can have chains of carbon atoms like this. Anywhere from 1 or 2 carbons to a chain that's 20 or 30 or thousands of carbons long. That gives carbon the ability to form so many different compounds. A couple of things that that you should be aware of is that a lot of times in organic chemistry, instead of writing all these dots, we're going to use dashes. We learned this before. So if you see 1 dash, that represents a single bond, 2 electrons or 1 pair. You may see a double bond between carbons. That represents 4 electrons or 2 pairs. You may even see a triple bond between carbons. That represents 6 electrons or 3 pairs of electrons, 2 electrons for each dash. Usually in this unit we don't write the dots. It's usually just the dashes because it is just a lot easier. So let's look at hydrocarbons. Hydrocarbons can be subdivided into 2 subcategories, which are saturated hydrocarbons or unsaturated hydrocarbons. Now, what's the difference between them? Saturated hydrocarbons have only single bonds between all of the carbons. These would be called the alkanes, and you'll see this on your reference tables. The unsaturated would be the alkenes and the alkynes. So this is the first thing. Saturated are the alkanes. Unsaturated are either the alkenes or alkynes. All the saturated hydrocarbons have single bonds between the carbons. They have the maximum number of hydrogens connected. So here's an example of a saturated hydrocarbon. Only single bonds between the carbons. We're not talking about these bonds. We're talking about the bonds between the carbons. They're only single bonds. If you look at the bottom, you're going to notice that there's an example. Here you see a double bond. Well, that double bond is an alkene, but you can also have a triple bond like this. This would be an alkyne. So both of these are unsaturated. The alkenes have a single bond. They can have more than one double bond, but they have at least 1 double bond between the carbon atoms. Alkynes have a triple bond between carbon atoms. But both of these are unsaturated. Alkanes are saturated, and they have only single bonds. And that's what they're talking about here, with the 3 dashed lines represents a triple bond. Let's look at the properties of organic compounds. Organic compounds all contain covalent bonds, so they're molecular, meaning they're only nonmetals. And we know that covalent bonds are extremely strong. They generally do not dissolve in water, and that's because they are nonpolar. Remember this phrase, extremely important phrase, not just in this unit, actually less so in this unit than the other units. Like dissolves like. So organic compounds in general are not soluble in water because organic compounds are nonpolar. And like most other covalent substances, they are non-conductors, which means they are non-electrolytes. Exceptions would be organic acids. They are electrolytes. They have low melting and boiling points because they have weak intermolecular forces, which means that they would have also, and this is not something that we see, high vapor pressure, meaning they evaporate very quickly, and they react slowly because they have covalent bonds, and covalent bonds are strong, so it takes longer for them to actually break apart. Last part of this, there are different different types of molecular formulas or chemical formulas when you're dealing with organic compounds. The molecular formula is the formula first that we normally have. It's just the symbols with the subscripts telling you how many atoms you have of each. Then you have the structural formula, and I'm going to show you how to go from the structure from the molecular to the structure. It's easy in this case. For example, this and this are the same thing. How did they get this? Well, you go with the carbons. I'm going to write 3 carbons first. You're going to put at least a single bond between them. And then each carbon is going to have hydrogens around it. And the way that you figure out is that, remember, every carbon has to have 4 bonds. So this carbon already has 1 bond, so you're going to put 1, 2, 3 bonds. This carbon has 1, 2 bonds already, so it only needs 2 more. This carbon has 1 bond already, so it only needs 3 more. And then you would put H's around it. As a matter of fact, in organic chemistry, it is certainly allowed to leave the H's out. Everybody knows that if you just put a dash, that it's an H. If it's an element other than H, then of course you'd have to put it. The condensed structural formula would be if you take this structural formula and forget about showing the bonds. Just put, you have carbon, and it has 1, 2, 3 hydrogens. That's CH3. The second carbon has only 2 H's. And the third carbon has 1, 2, 3 H's. And that would be the condensed structural formula. So you have to be able to go in this direction and in that direction. And I'm sure we're going to be practicing that as we go through the unit. And that is it for